Hello there, thank you for tuning in. Today we're going to connect two computers. One computer connected to another via Ethernet cable. For this exercise I'll be using some tool called Packet Tracer. It's a tool that you can freely download from Cisco, and once you have this configured, you can actually just launch the application. You can connect with a guest user, no need to register or whatsoever. Let's wait for the application to launch. There we go. So that's what you see when you launched Packet Tracer. And the next step will be to just go into End Devices, choose a computer again, and the next step, just go down to Connections, select the crossover, click on one of the computer, Fast Ethernet, towards the other one, Fast Ethernet, and there we go. Here we have these two computers connected. Pretty good. Now that was for the physical layer. That's the physical part of connecting these two computers. Now we need to work on the interfaces, on the TCP/IP configuration, which means we are going to give these two computers an IP address so that they can communicate with each other. So let's take this address, for instance, with the MAS24. Well, the MAS24, an IP address is usually written on base 10 notation, but behind the scenes this IP is represented by binary. So each portion represents 8 bits. So let's represent that in binary. 1 2 3 4 5 6 7 8 16 24 32. So that's the extension of an IP address, and I have made this little table, and to explain a little bit how it works. The IP address, we have numbers going from 1, starting from the right hand side onto the left hand side. We have numbers going from 1 2 4 8 16 34 64 and 28. Each of those positions can be represented here on the portions of the binaries. So in order to convert this IP address onto binary, we just have to take that 10 and we start from left to right, and we'll start seeing where that 10 will fit, right? So yeah, it fits in the 28, but we have many numbers left. If we continue looking, we find that right here it fits. I mean, the 8 fits in 10, but there are 2 left, so we need to turn on that bit, the bit represented by 8, which is counting from right to left is the second, the third, 4 bit. So we just have to turn on that 4 bit on. We go 1 2 3 4, we turn it on, and we still need to find the 2, which is the second bit. So we turn on the second bit on, and that makes 10 for the first octet. The second, we have 0, so we just fill in 0, and for the third one we have a 50. The process is exactly the same. We look from left to right, where will that fit? So we find out that we need 32 plus 16, that's 48, plus 2, that will make up 50. So we turn on those bits on. 1 2 3, the third bit we turn on, we're working on this one. This next one turned on, and the second from right to left turned on. If we add all this together, we end up with 50. So that's 50 here, and the last one is 0. So we still need to figure out how this did that 24 come into existence. So that's pretty easy. We just have to consider this structure, and 24 what means is that this is called a mask, network mask. What it says is that 24 bits starting from left to right are turned on. So we turn those bits on. 1, 2, 3, 4, 5, 6, 7, 8. So that makes 24 bits turned on. 24 bits turned on is how this mask is represented. And if we convert that IP address onto base 10 notation, we end up with 55 to 55 to 55.0. So you might be familiar with this type of addresses in your network mask when you're configuring TCP/IP, and that's what it represents, 24. So what that means is that our mask covers this region here. Everything to the left, everything what's covered by the ones, is what represents our network portion, and what goes to the right, that is the host portion, which means that the requirement for two computers to be able to communicate when they are connected in an ad hoc type of topology is that both IP addresses are located in the same portion, in the same segment of the network, in other words, in the same network. So they both need to have the same mask, but also the addresses need to belong to the same network. So how do we determine the addresses of that portion? It's pretty simple. We have to permutate these bits right here on the portion, on the host portion. So if we need to, let's say, connect the create the first IP address, that will be like this. That will be 1 because that's the first bit, right? If we want to, let's say, assign another IP address, that will be right here, the 2, right? We know that they both are in the same network because these stay the same, these remain the same. The network portion is the same. The only thing that changed was the host portion, right? So we have here, we can connect as many computers as we can play around with these bits, right? If we take 1, 2, 3, 4, 5, 6, 7, 8 bits, but 1, we will have this number 254. So we can connect all this, we can choose from this range of IP addresses for these two computers as long as we maintain the same mask. So let's go ahead and assign IP address 1 and IP address 2 to these two computers. So we move to this computer right here, desktop, and we choose static. It's already pre-selected, and we give this the mask 255, a 24-bit mask 255, and that's it. We don't need a default gateway because this is an ad hoc connection. That's it. For the second computer, we do exactly the same. We move on to the IP configuration. We give this one the IP2 and make sure that the mask The subnet mask is the exact same 24-bit mask. That's it. So now if we try to ping computer 1 from here, we'll see that it replies. If I ping myself, it will also reply. If I ping from the other computer, and this is pinging myself, of course it replies, and I ping the computer 2, it replies. So that is how you connect one computer to another. You can also do this on a real life scenario just by using the correct type of cabling. And that's pretty much it. I hope it was helpful. Thanks for watching.